Hello guys, welcome back to the C# tutorial. This is Gopi back with another video. In this video, we are going to discuss about how to implement binary search. In the last video, we were discussed about to do linear search algorithm, and now we are going to discuss about binary search. First of all, what is binary search and why we need to learn this? Binary search is actually comes under divide and conquer algorithm type. What is meant by divide and conquer algorithm? You just wanted to keep it simple. Whatever the data you give it as an input, you just try to split the data into two different parts and then do search operation or whatever the operation that you have written, either part of it, and that's what divide and conquer algorithm. Since binary search comes under divide and conquer algorithm, we try to split the data into two different parts and then search it. Are we going to divide only two different parts, or else are we keep on dividing the element till we find the specific element from the array? Binary search keep on divide the collection until you find the specific element. That's what binary search did. One thing that you wanted to find out is you have to always implement binary search only on the sorted array. If the collection is not sorted, then obviously you will not be able to get the data. The first requirement to implement binary search is to sort the array and then have to use it. If you look at the input I have in the main method, you can see I have two different input variable. One array is not sorted, another array is sorted. Since I am going to use binary search, I will be using only sorted array. If the array is not sorted, then obviously binary search will not work. Always keep in mind. That's how we need to do. So the first thing is you will be implementing binary search only when the collection is sorted. Second thing is you must have to find out the middle element and then you have to either go to left side or right side to implement the search functionality. These are all the things you need to keep in mind. So first and foremost what I do is let me try to create one new method within the class binary search. Public. The main method is static, so obviously I have to use static here. I will just keep it as integer or the return type, and then I am going to do binary search implementation. So this is the method that obviously going to return. If suppose the element is not found, then I will be returning -1. I have invoked this member in the main function. Now, what is the collection and what member I need to search for? So, let me introduce integer array, which you can consider it as an input array. So, in my case, I just consider it as an, we can consider it as an input array itself. And then you can use what is the element that I wanted to find out. So, that is again going to be an integer. And then you can find anything. I just keep this one as a key. This is the key that I am about to find out. I can just pass the first parameter as input, the second parameter as 45. So now we are done with the basic setup. We have an array, right? So within this array only, we are going to do the search operation. I already explained binary search divide the entire collection into two different parts for each and every iteration that we are doing. Let's implement that part. If you wanted to find out the middle element, then you need to know what is the start index, what is the end index, and then you have to divide that by 2. What is the start index? Always going to be 0. What is the end index? Always going to be the total length -1. That's what start and end. But the case is, this is the start and end for the array for the first iteration. After the first iteration, we would have divided the array, right? So in that case, 0 will not be the first start index, the n -1 will not be the end index. The index always going to change. So what I do is, let me have integer start default going to be 0 and then integer end equal to your total length. What is that array? Input array dot length -1. This is what start and end. So now we know what is the start point and we know what is the end point. But the thing is, we need to keep on divide the array or else the collection into of till I find the value. So how could I do that? While loop. If suppose end value, if suppose the end value is actually greater than equal to start. Now within this loop only we are going to do our work. So the first and foremost is we need to find out the middle element. How to find out the middle element? Let's have integer mid element equal to what is the start index and what is the end index, and that's what we have to use. So start plus end divide by 2. Leave it this, right? End divide by 2 will be the first operation and then it will go for the plus operation. So I don't want to do that. So to avoid the precedence issue, I just enclose plus operation within the bracket so that it will work first and then it will do the division. So after this operation, I will be getting the mid element value. Now I have to split the array into two different parts. Start index to the mid plus 1 to the end. So how do I do that? Itself is the one that I am searching for. Then that needs to be verified here. If suppose your mid element input array of mid equal to the key, in that case return whatever the value that you have find out, return the mid value, because we know what is the key that we are searching for. Okay, we only don't know the index, or else whatever the data you wanted to return, you can return it, shouldn't be an issue. Now what if the mid element is not the one that you are searching for? In that case you have to either go for left side or right side. Here if your input array of mid lesser than whatever the key you have, now you need to go whatever the end equal to mid plus 1. In that case the end value alone I just modified it. If suppose it's not the case, then I should go for the else condition. In this case I have to go for start equal to mid plus 1. So this is how you need to implement that binary search. Let me explain it one more time. First, binary search implementation is this: you got the entire collection. In this collection you wanted to find out this key. What I do is I am just find out the start and then the end index. If suppose the end is greater than a start, till the condition I have to execute the while loop. If till while loop runs, if the element is not found, in that case the element is not available in that collection itself. In that case I am returning -1. If suppose the element is available, in that case I am returning that specific element index. Integer mid equal to start plus end divided by 2. I wanted to find out the mid element for each and every iteration. So that's why I have using this formula. So what is that? Start index plus end index divided by 2. I used bracket to overcome the precedence. If suppose mid element is the one that I am searching for, in that case I am just returning the mid. And then if suppose mid element is not the one that I am searching, in that case I am just going for your element, whatever the element that present in the mid, which is lesser than key. In that case I am go ahead and do the mid plus 1. Okay, it should be -1. If none of the case is there, then I am changing the start index. Now what I do is, let me get a value here, integer result equal to, and then print that result here. Now what I do is, let me try to press F5 and see whether the implementation works perfect or not. So here you can see I got a 2 in the output screen, so which is nothing but your second index. So 0, 1 and 2. What is at the 2? 45. So I am searching for 45. So this is working as expected. So what I do is, let me try to change this value to 145. I know that 145 is not available in this array. Let me run the program again and see what I am getting in the output screen. The expected output is -1. So here you can see I get -1 as we expected, because 145 is not available in the collection. So this is how you have to implement the binary search algorithm. Keep in mind, if you have a list by default have a binary search method that also can be used, but it is always mandatory to understand how to implement this algorithm. That is why we are using it. Let me demonstrate that. This is your input, right, where your result 1 equal to input dot to list. If I convert the array into list, then I can use binary search, and then I can pass any item, let's say example 45. Likewise also we can do the binary search algorithm. We will meet in the next video. Till then, bye, take care.